Semiconductor. My name is Maurer and I'm acting as Product and Application Marketing Manager responsible for ADAS applications as well as PMICs and DC-DC regulators for the automotive industry. Today, I want to talk about a new innovation of our engineers named QuiCur. QuiCur Technology is a brand new technology for bug regulators with optimized transient load responses at high DC accuracy. This new technology allows to reduce the number of output capacitors down to a single and reduces the requested PCB area to its minimum. Transient load responses. Here the two major effects. Voltage droops caused by heavy load conditions at the moment the high side switch is turned off by the regulator. There is a strong discharge of the energy stored in the capacitor, and furthermore the regulator's control loop needs significant time to recharge the capacitor. As a result of this, a voltage droop at the buck output voltage is noticeable. Similar behavior can be seen when a heavy load is released exactly at the time the high side switch is turned on. High energy is loaded via the inductor into the capacitor and results in a voltage overshoot. The loop control will need some time to react and absorb the energy via the low side switch. This slide shows the error amplifier dilemma of bug regulators. Bug designers usually have to compromise between speed and accuracy. High DC output voltage accuracy result in a reduced control loop speed, and a high control loop gains can significantly reduce the phase margin of the bug regulator. Higher output capacitor values of the bug increases the voltage accuracy, lower the AC ripple and transient voltage droops and overshoots, whereas less capacitance fasten the response time. As said, a design dilemma. All designers have to compromise. QuiCur is a method invented by our designers to overcome the accuracy-speed dilemma. This invention allows to have both high accuracy and high-speed feedback loops integrated in one single bug regulator. Therefore, the feedback loop is split into a high accuracy path for exact output voltage settings. This path operates with slow speed in order to set the exact DC average output voltage, and the high-speed path with fast response times to avoid voltage droops at the bug regulator output, and passes the slow high accuracy path with priority to react fast on output voltage fluctuations. Please have a look to the three PCB sections. The left one shows today's typical bug design, including 4 output capacitors. The output voltage droop of a 2 amp transient pulse with a slew rate of 1 amp per microsecond is measured to be worst case 30 millivolt. The PCB in the middle shows the next generation bug regulator with no external compensation network, as well as half of the former output capacitors, achieving even better transient load responses with a droop of only 25 mV. While changing the mode pin of these new bug regulators, the output capacitance can be reduced to 1 × 22 microfarad only, and the voltage droop for the same transient load pulse is only 10 mV more than the original one. As a summary, QuiCur is an invention for switching DC-DC regulators with fast transient load responses, offering 20% lower voltage droops with half of the original capacitance. These new designs offer configurable loop gains for sufficient phase margin even at lowest output capacitance. The voltage droop at smallest capacitor values will only be increased by 10 mV to comparable products. This new invention will allow to reduce the requested PCB area to its minimum at lowest BOM cost. As mentioned before, the phase margin is an important attribute of the stability for a bug regulator. Both graphs show the gain in red and the phase in blue of the new BD9S402 MUF-C bug regulator. On the left graph, the mode pin is set to high, means high gain, whereas on the right side, the gain is lower, the mode pin is set to low. As you can see and read, the measurement of the right-hand side setting provides a significant lower barrier frequency with a much higher phase margin for the same output capacitance of just 1 × 22 microfarad. The new bug regulators will provide a configurable compensation gain to ensure sufficient phase margin for stable switching regulator designs. Users can select the number of output capacitors based on the maximum allowed droop voltage. Here you can see the summary slide of 2 bug regulators which are currently in evaluation and will be released to mass production at the beginning of next year. The bug regulators offer a guaranteed output current of 3 and 4 amps and come in a very small 3 by 3 mm QFN package with wettable flanks. The bugs include safety functions like overcurrent protection, short circuit protection, thermal shutdown and more, and will be qualified according to the automotive standard AEC-Q 100. As mentioned, the bugs include the QuiCur as well as nano-pulse control technology and offer outstanding electrical performance with very fast transient load responses. As a summary, ROHM's QuiCur technology offers cutting-edge new DC-DC regulators with fast transient load response behavior for lowest droops and overshots, switching at high frequencies with configurable compensation gains and integrated phase compensation network. This allows to reduce the number of output capacitors to its minimum for lowest BOM cost and smallest solution form factors. QuiCur technology is the next step of miniaturization paired with lowest BOM cost in the automotive industry. For further information, please visit our webpage under rohm.com/products/power-management/switching regulators or contact us via rohm.com/contact us or register to my ROHM.